Hi everybody, my name is Simon Holmdahl. I am a 3D artist and motion designer at Man vs Machine. And today we're going to be talking about Houdini versus Cinema4D. Should you keep investing your energy into the software that you're already using, or should you learn a new one? This is a tricky decision tricky thing to overcome, and it took me over a year of considering this before I started learning it. I've now been using Houdini for a year. I still use Cinema4D, but I think that they really complement each other quite well. Those two tools are good at completely different things, and now I have the choice. I can use the right tool for the right project. So some key benefits and strengths of Cinema4D, first off, and what got me onto it all those years ago, was its ease of use. I didn't even want to get into 3D when I first started out. I was using After Effects and I was perfectly happy doing just 2D stuff, until I realized that that doesn't really work. And the only reason why I even considered doing 3D was because cinema was easy enough to learn. It's a really good starting point, you know, and especially now, there's a lot of developments, there's a lot of good renders out there, and you know, you have X particles and TFT and all these things. Those things weren't around when I started out, but yeah, so Cinema4D is a great tool, and I tend to use it a lot for previs, camera work, and designing style frames and that kind of thing. Houdini, on the other hand, its strength lies in its incredible depth. There's a lot of functionality there, and there's a lot of flexibility. All information is open and you can access it and use it however you please. Because there's so many small things you can tweak and stuff, you're gonna end up spending a lot of time doing that. If you didn't have those options, you would work quicker. So you have to kind of balance it and figure out when it makes sense to use a tool like that. It kind of depends on the person you are as well, obviously. It's very fast as well. In cinema, as you may or may not know, a lot of the core of the software is unfortunately not multi-threaded yet. I mean, there's a lot of developments in this area, and I'm sure in a year or two it will all be multi-threaded and super fast. But as of this point, Cinema4D kind of doesn't take the advantage of hardware that well. My point is, if you have a 24 thread machine, or a 48 or 72 or whatever, you will probably be bottlenecked at like one thread. You will be using 1/24 of your machine for the majority of tasks that you're doing in Cinema4D. So it kind of gets slow for that reason. Houdini, on the other hand, has a lot of multi-threading. Like, there's a lot of stuff that are running across all your threads and utilizing much more of your hardware. Houdini is traditionally used in visual effects, and for this reason. They always focus on making it more scalable and faster, which is the two things that are most valuable to people who wanting to push the limits a little bit. So yeah, two completely different tools, and you know, it doesn't work for everyone. Like, if you're the kind of person that just want to get an image created, you know, get a nice looking image on the screen, you don't care how it's done, you don't care if you painted it by hand or sculpted it or, you know, rendered it or simulated it, then maybe Cinema is a better tool for you, because it's much more to the point. Houdini, you need to kind of go the detour. There's no shortcuts. You have to kind of like work your way up from the ground. If you want to, you know, use this, you know, in cinema, you use a spline wrap to wrap a shape around a spline. Forget about that in Houdini. You have to kind of build that shit. You have to build your deformers. But because it's so granular, it also allows you to build your own tools and make it work the way you want it to work. So there's a lot of interesting things that can be done there for sure. But you know, you should be really clear in your intentions. If you don't feel like you're being held back by the software that you're currently using, then there's no reason to learn anything else. You should learn it when you have to. That's what I think anyway, because that energy can be spent learning something that is more important. So let's just head on into Cinema and Houdini and have a look at how they are kind of fundamentally different. All right, so this is Cinema4D, as you know. I've just dropped down a cloner object and a cube, deformed it a little bit, and then added a dynamics tag, random effector, delay effector. You know, it's nothing complicated about this, but you know, this is what makes Cinema really powerful. This kind of stuff would take a lot longer to set up, especially with the dynamics part in Houdini, and it's what makes it powerful. But if you needed to take this a step further, you know, start to manipulate a single specific clone or needed access of the points or the information about certain objects, it's really hard to get to. So the first thing you have to do is obviously cache, because we have a delay effector, we also have dynamics. So let's cache this here. The next thing we need to do is drop down we can actually do a copy of this. Hit C on it and then go in and delete all these tags. So now we have a copy of our cloner object, and now we can link it up with that using Espresso. So let's drop down an Espresso tag. And then we need object index, we need a hierarchy. Sorry, I'm not going into detail about how this works, but data. So data reads cloner objects and MoGraph data. So let's just bring in our cloner, link it up here with our data node. Then this gives us our index together with the hierarchy. So basically we're going through all of these null objects here, and it gives us the index of each one and matches up with the corresponding index of the cloner object. We need a placeholder, so I'm dropping in a null here, feeding that into the object, taking the global matrix and plugging that into there. So I have an old tutorial on this. Go back my Vimeo channel, you'll find it. But basically, this is how you would access information about your clones or your MoGraph data. So this is great. So now we have the same thing. We have everything moving the way we want. And now the benefit is that now these are actual objects. So you can go in here and manipulate these now, whatever you need to do. So we can go in here and, you know, remodel them or move the points around, you know, that kind of stuff, and it will still move the way you expect it to. And you can add your deformers or whatever you want to them. But the fact is that you shouldn't have to copy everything like this. If you have a more complex scene, I found myself like doing this 4 or 5 times, and your scene got incredibly slow. You had to Espresso lag because of priorities, and it's just a pain in the ass. So nowadays, whenever it gets any more complicated than this, I just tend to go into Houdini. I just cleaned up my interface a little bit for the lack of screen real estate I have here. My computer didn't allow me to record at a high resolution. It just died on me when I tried. So hopefully this should work better. So here's the this is our object. So this is the equivalent of the object manager in Cinema. And I'm just going to drop down a empty geometry node, which is basically just an empty object. So by default, it drops down this file node that reads in a file from disk. And we're going to delete this, and we're going to start by dropping down a sphere, for example. I'm going to use the sphere as a volume to scatter points in, so that we can clone our objects onto it. So let's start off by doing so. So in order to create a volume out of this, we need to use a ISO offset, and we plug this into our sphere, and it creates a volume for us here. And you can set the sampling quality of this voxel size or whatever on our fog here. It's not too important for our purposes right now. And then we drop down a scatter, and this will scatter points in our volume. And you can set how many we have here. So I'm just going to do like 80, 90 points. And then we want to animate this point. So I'm just going to use this. You can do it in many different ways. I'm going to show you something which is called VOPs. So this is an attribute VOP. This is essentially a programming language in a visual sense. It's a node-based programming language. And it's this similar thing to like the equivalent of Espresso, I guess, in Cinema4D. This is the visual way of writing Vex. So you can use a Wrangler, which is basically a code snippet where you type in your commands, and this is the node-based version. So I just dived into this node by using either double-clicking or hitting I. So I basically goes in and O goes out. Or, sorry, no, U goes up. In, up, or whatever it stands for. So let's go into that. And basically the way this works is that you have inputs here and then you have outputs here, and you can modify the information and then output the new and updated information. So what we're going to do is drop down the noise. So this is a turbulent noise, and you can choose to output a 1D noise or a 3D noise. This basically is float, and this is vector, and we want vector because we want positions in 3D space. We want to offset position of these points. So we're gonna feed in the information that it needs to sample the noise field. So this is the position of the points, the original position, and then we're gonna add the output of that together with our current positions. Because if I just plug this in here, it's gonna drop them all down to the origin, which is not what we want. We wanna add this new noise value to our current position values. So we're adding them together, we're outputting the difference, and now we can see that we can manipulate the position of our points here. We can change between different types of noises here, but we don't need to go into that detail now. Okay, so in order to get this to animate though, we need to animate the offset here. So there's a couple of ways we can do this. We can use the time here and convert it to a vector and then input it into our offset here, or we could just promote this to our top level. So that's what I'm going to do, and this essentially just makes this this input here available on the outside of this node. So now we can see here, if I select this, we have this offset promoted to this level, and we can now animate this if we want, or we can use an expression. So I'm just going to drop down $t, which basically means time. So now this will move on itself. If it moves too quickly, we can divide this with a value, and now it moves slower. So this is good enough for our purposes. We're not going to bother by doing the dynamic thing we did in Cinema. We're just going to keep it simple here, because it's not important what we're doing, it's just showing how it's fundamentally different. So now let's create our object that we want to put on these cubes. So we use a box, for example, and we want to model it. We had a tapered edge before, so I'm just going to try to scale this down. Let's see here. Wow, I selected too many polygons there. My apologies. Hit S to select, T to transform, see E for scaling. So I'm just going to scale this, T to transform. So here we have an object now. So now we can copy this onto our points using a copy. So it's a cloner object essentially. The first input gives us our primitives, and the second input's the template to copy to, which is the points, and this is our primitive. And you middle mouse click to get this information, by the way. Excuse me. So here we can see our cubes are way too big, so we're going to drop down the transform in order to scale them down. And I'm scaling them down before I copy them here. So I'm just going to take the overall scale down, and that's that. So now we have our cubes and they're on our points, and because the points are animated, these cubes are moving. So now we have a similar thing. It doesn't have all the rotation stuff, but I don't want to make it too complicated for this video because it's already really long. Apologies for that. But the cool thing here is if you wanted now to get some information about, for example, this one here. So let's zoom in on this. If you wanted to access this polygon, all you have to do is select it. And if you wanted to place something on that polygon, you could just delete it. So now we've deleted it, and we can, that gave us this blast. And if we take this and we take delete non-selected, we're left with only this polygon. And the beauty of this is that this still has all the information. It still goes through, and we still have the whole object before we delete it available to us. So we can do whatever we want to this number, this one polygon here. So we could, for example, go in and modify this further. We could go and scale it. We can we can drop down a poly extrude. You know, it doesn't matter. We can do whatever we want here. And I'm gonna just extrude it, add some subdivisions, and twist it. You know, and this is now following that information, that animation that we had. And if we wanted to put it back onto the original clone here, all we need to do is merge it. So we do drop down a merge here. We take the information before we copied it, or before we deleted it and separated it. And there you go. And now we have both. And the reason why it looks a bit funky here is because we have, this is just one of the things here. We have normals here, but we don't have normals here. So we just need to drop down a facet here to generate normals on our polygons there, and now it looks the way as it should. So now if we look at this merge, we should have, a scale, I accidentally moved this here. So let's just delete the edit for now. There you go, now it's matching. My apologies. But there you have it. And now we actually have both of them, and we can still go in and tweak here. So let's say I want more segments or less, or want to tweak the distance and that kind of shit. So we have a lot of control over how we do this, and it's non-destructive. That's the best thing about it. We still have the original stuff. We never deleted anything. And another cool thing is if we decided later on that, oh, actually I want to add this to not just that one, but I want to add it to that one and this one, for example. We can then go in and show the primitive numbers. So this is 484. So let's add that one here as well, 484 onto our blast, and that will basically delete both of these now. And if we do the poly extrude, it does it to both of them. So now we've essentially applied that to both of them, and it's completely non-destructive. And we can even take this a bit further. You know, now it's moving like this. We can even now go in here and deform and modify these separately. So I can move this point. I actually want to scale it a little bit, or move it over here. Whatever you need to do. And it just drops down edit. And if you regret it, you can just either turn it off or leave it. And it applies this deformation as it moves. So this is just a quick example of how Houdini is fundamentally different, but this is really powerful. You can see how useful this could be. It's just adding everything procedurally, and you don't have to make your selections yourself like this. You could also delete randomly. So if we wanted to do this operation to a percentage of our primitives, we could go in here and drop down a actually we can do a group. Let's do a group. It's probably easiest. So we're just going to go in here and we can use group by expression, and we're going to do rand $ID, PT, no, PRNum, primnum. I don't remember what it's called. Let's see if that worked. So yeah, so that's definitely worked. Greater than 0.5 or 0.6. So this is now, if you see here, it says highlighted by operator. 221 are selected. You can also see here in the viewport. So that's now 60% of all our primitives. So random gives us a random value between 0 and 1, and this, if that value is higher than 0.6, it selects it. So let's just do a little bit fewer than that. So 10% selected, and then instead of in our blaster, instead of blasting everything, we can blast that group. So that's called group 1 now. You can rename them here if you want. And it's now done that, applied that same transformation to all of these, procedurally, and we can change the seed value here if we want to. So just by adding another number, we'll get a different result. And this can be, it's limitless what you can do, and it still moves. So that's the power of the procedural nature of things here. And we can, go in here and change the point count. It doesn't matter. Everything is like flexible, and as you can see, it's really fast. Like I'm doing this on I mean, it's not that fast. But yeah, on a lot of points here. It's pretty impressive. And you can change out, let's say you didn't want a sphere here to be your source, you could do a tube instead. Now plug that in instead and get a volume which is a tube. We scatter in that. We can take a torus, might be better, a bit more clear to see what we're doing there. And the end result is that we have this now applied to torus. So, you know, it's pretty cool. This is just an example of nothing that you necessarily want to do, but you know, it shows the differences and the benefits of the different softwares and their strengths. All right, thank you for watching this video. I apologize for making it so lengthy, kind of rambled, and I needed to show a lot of things at the same time. So sorry about that. I'm going to try to keep them shorter in the future. If you have any suggestions on what you want to see in the future, let me know. I don't know when the next video is going to come out, so I don't even know what it's about. I have a feeling I'm going to be very busy in January and February, so we'll see. But thank you for watching. If you want to get in touch, here's my contact information. See you in the next video. Bye.